Okay, so now we are going to look into the estimation of this fuel consumption using Matlab and the artificial neural network tool in Matlab. So here I open my Matlab, and here you can actually select your working directory. So here you can browse and actually select the file where you are working using Matlab. Okay. If you do not have Matlab, you should download and install it. So normally institutions do provide access to Matlab. For example, for USN, if you go to this apps.usn.no, here you will find the Matlab here. Okay, you can download and install. So before starting this, you have to make sure that you have Matlab installed, and then you open Matlab. And after you open Matlab, you will get a window like this normally. Okay. And here you go to these apps. And normally when you do the installation, it is recommended that you say that you are going to use some of the tools. So Matlab has actually a lot of tools, but the one we are going to use is neural net fitting, okay, for artificial neural network. But also I recommend that you also take the regression learner. Okay, so these two, regression learner and this neural network fitting, these two are pretty good when it comes to these machine learning applications. Okay. So we are going to use the artificial neural network using this neural net fitting. So I'm going to run this. And here you get the window for artificial neural network. And here you get some information. So I already explained a bit about this information that you see here, sigmoid and hidden neural networks and the back propagation algorithm, how they work and so on. Okay. So I already explained it in the machine learning. I explained it broadly in the when I was explaining the artificial neural network model concept. So you can also read more if you want to. So Matlab, they have a kind of, what do you call it, like a tutorial book where they provide a lot of details about all these models and algorithms and so on. But now we are mainly going to implement it. So we're going to click on next. Okay. And here in Matlab, they want you to provide their inputs and outputs separately. Okay, as you can see, input and target. Okay. So for that reason, we actually created two files. One here with the clean input batch. So if I open this file, so here you will see that I don't have really any other variables except for my main independent variables. Okay, so only those are the ones we see here. But by now, when running the multiple linear regression, we already learned that actually there is no point in using the draft oft. So I can remove it. And when I remove it, then we have this problem that it is connected with the trim. So let's say if I select all of it, I press shift and control and the down arrow, I select all of it. Then I copy it. Okay, I copy it with control C. Then I go on the top. Then I go on the top on this cell. And then I'm going to paste it as numbers. Okay. So now I should have done it for trim. So if I go to trim and I press shift control and the down arrow, and then I copy it. And then I go here on the cell here for trim, and I'm going to now put this 1, 2, 3. Yeah, best values as 1, 2, 3. So then if I remove this, nothing happens to my trim. Something happens to min draft, but we also learned that this is useless. So we are going to drop it as well. So these are the 6 variables we found that are really useful. So I'm going to save it as Control S. So here you see in the input, we are going to load this one. And for the output, we are going to load this one, the clean output. Here we have exactly same corresponding row. And we have this information with fuel consumption. You have to make sure that they are exactly the same corresponding row with the input values. Okay, so the independent variables on row 2 corresponds to the here the dependent variable value in row 2. Okay, you have to make sure that. So normally the idea is that you do all the kinds of manipulation and formatting and dropping of values and so on before you split the data into input and output Excel files. Okay, but we have done it here and we are going to use it now. We have already seen from multiple linear regression that the models where we have very small RPM and speed doesn't really fit well, but that's okay. We are still proceeding with that one, but I would recommend you that when you try this one, but also another model where you drop all the observation with speed, let's say below 7 knots or 5 knots. Okay, and you can see if the model improves. So I'm just going to close it. And here I'm going to click here on browse. And then here I'm going to select this one, the clean input batch 1. And here I'm going to also select browse. For some reason it's working a bit slow. Yeah, only now I get the values loaded for the input. So I just click next, it looks okay. I click finish. And then here I think I can close it. I can also close it. I think I'm just going to do it again. Okay, I click on the target and then I select the clean output. I click OK. And then here I get the preview and here I get, yeah, it looks okay. I get finish. Here you see this was updated as data 1, but here it was not updated. So I'm not sure if it was loaded properly. So I'm going to do it again. And I select this one. And then next, and then finish. Yeah, now you see my input data is data 2 and my target data is my dependent variable data is data 1. Now they're loaded properly. Okay, here we still have one problem, that actually our samples, they are on matrix row. Okay, the number of observation, they are on matrix row. So we select the matrix row. Okay, then we click on next. So in machine learning, normally we can do the estimation of the model. Normally we divide the sample into data, training and test, but sometimes we can do it as training, validation, and test. So we estimate the model parameters, the weights of the artificial neural network model using the training sample, and then using those weights and the value of independent variables, we do the forecast for the validation sample and see how well it was performing. And then if it was forecasting, it was performing well, then we use the same weight and then forecast the values for our test sample and see how it performs. Okay, and normally it is a standard practice to use actually 70% and then 15% for validation and 15% for testing. Sometimes people also use 80% on training and 10% validation, 10% testing. So both are fine. Normally, often those who are very interested in these, they would try different combination of these and see which one gives better results. Low error, okay, low RMSE, okay. But anyway, so now let's move on. Next. Here you see we have this setup, how many hidden layers we want, okay. If I go to the paper, we see this figure here, right? As you can see here, there are different figures. So here you see the first one is with 10 neurons. The second one is with 20 neurons. And then we have 15 neurons. Then we have 50 neurons. That again, we have 10 neurons. Okay. And they did it for the 6 SHIP categories, but they use different neurons. Normally you try several different neurons and see which one gives you kind of the lowest one, and then you will pick that one. But here we're dealing with only one vessel data. So what we can do is we can try with 10 neuron and then we can try with 20. So normally people do like 10, 20, 30, 40, 50. That's how people normally do in machine learning and big data applications. But let's do it with 10 and see how it works. So let's say we do it with 10 and then we go next. And this is one of the most widely used algorithm actually. So we can go with this, but here you see they also provide us few more options. So if you select this one, that's okay. Sometimes you want to do the 3 different one and compare the results, but for now we are going to proceed with this one, and then we go with train, and then we got our results. Okay, and we got our results here. If I click on performance, the performance are being generated. So here you see epoch, there was 11 epoch. Okay, and here you see how the train data performed, how the test data performed, and how the validation data performed. So in general, it says that the mean square error that reduces significantly after 5 epoch. Okay, so sometimes it is a good idea to take a screenshot of these, and also or you can, I think, actually copy it from here. Yeah, you can save it, and then you put like this figure, okay, with your results and findings. So I'm going to close that. If you want to see fit, yeah, the fit is not going to work when we have more elements. But now let's say if I close this, normally you will see that people also take a screenshot of these results here and then present it. Okay, sometimes you will see also people present this error, how the errors look like, okay, for the different samples. Then also sometimes the regression fit, how well this regression fits actually. So here you see when R square is like 0.8, that's pretty good. Here also R square, yeah, R squares are really good here. So R square normally means that our independent variables together can explain, for example, if I look into the all R square for the whole data, then our independent variables together can explain 90% change in the dependent variable. Okay, for our training set, our independent variables could explain about 91% change in the dependent variable. If I quickly look into our regression results from before, if I go here quickly and look into our multiple linear regression results from before, here you see the R square was 74%. So our independent variables together, we using the regression could explain 74% variation in the dependent variable. You see, so using the artificial neural network, we actually improved our performance quite a lot. And you see this figure, they are also nice to present in the paper. As you can see, they presented here. Okay, for all of them, they took a screenshot and put them in a table format here. So now you kind of get the idea how actually people get these figures and then put them here. Okay, great. So now we could generate the results, but now we also want to forecast for these values of future values. Okay, for that, one idea could be to also load this data, in Matlab, and then we try to use the estimated neural network model to predict the fuel consumption. Okay, but before we go there, let us first now close these things. Okay, from here we could get the feed, but now let's go next. Here we have some options for code generation and application of the estimated model. So in general, what I would like to do is I would like to generate a code. So I'm going to click here to generate the code. The one we got from here, these are mainly for if you want to deploy them in a web tool or somewhere. Okay, so this comes with all the weights and everything, but we would like to mainly first go for these codes. We want to get codes, so I clicked next here, and here we have two options for simple code and advanced code. So let's see if the simple one is going to work well or not. Okay, so let's try with the simple code, and then we get something like this. Okay, here, yeah, that's what it looks easy and simple, right? So we get something like this, and normally I would like to also save it. So save as, let's say, energy efficiency. I'm going to call it class. So if I run all these codes now, it will generate normally the same result that we already have generated. Okay, and now what we want to do is actually we want to make a prediction for these observations. But the thing is that now we have to load these observations in the Matlab to get their predicted fuel consumption. So what I'm going to do is I'm going to copy this, okay, and then I am going to create a new Excel file here. I'm going to call it optimization Matlab, and then I'm going to just open it and paste the values that I have copied. I'm going to drop these two because we are not going to need them, and just save it like this. Okay, now then I'm going to try to load it on my Matlab window. So let's see, here I am. Okay, and here I am going to try to load it. So let's say if I try this code here to load a new data, if I just try copy this, and if I put, so in Matlab to make any comments, we can use the percentage symbols, and then we are going to say load out sample out data for optimization. Then I just press this. So this will be my new variable name, but here my data file name should be optimization data, optimization Matlab. Okay, that I created just now, but I'm not sure if it's going to work. Let's give it a try. Let's give it a try. It is going to work, I guess. So here I wrote this line of code to load the data in Matlab, but most likely it's not going to work because first we have to import the data in Matlab. Okay, and to do that, we can go here on home, and here we have the option to import data. And here I can select this optimization Matlab. And yeah, that looks right. So here we see that variables name row is 1. That's correct. On row 1, we have the names. And then here we say import data. Let's see what happens after that. We have successfully loaded our data, I think. Yes, it looks like that. So now in here, we do not have the space in between. So if I just copy it from here, and if I put it here, it should be working fine. Okay, and then to make prediction using this model, okay, we need two more lines of code, one more line of code. Actually, we can copy this and I can put it here. So here A will be our like the prediction calculation, and here the net is to net will fetch our optimized our estimated a neural network model, and this is the file name from where we'll pick new inputs. And let's say here we are going to put 1, so that means it will pick the first one row. Okay, now let's just run the model. Okay, now let's just run the model. If I click here on run, everything runs again, and yeah, everything runs again, and in the end I get this. I should have gotten this output, but which I didn't get. Did I? No. Here says line 192. Here we have some CT transport for table. So here we have some error, but I'm not sure what caused it. Let me have a look. So we were getting an error when we were trying to do the forecasting with the outsample data, but now I figured out the issue. So what happened was that when we imported the new data file, the optimization Matlab file, then we imported it as a table. But here we have to import it actually as a vector. Okay, so to do that, you can go to home and then you go to import data, and then you select the data, your outsample data file. And here in output type, you have to actually select this numeric matrix. Okay, you have to select the numeric matrix. That should be the type. Okay, and here the variable no names are in the first row, and then you select okay, import data. Okay, and after you do that, then you can, let's say, create a new data here in the script, which you call the name of this file that you loaded as a vector, as a matrix. Okay, so you have to exactly copy it from here and then paste it here, and then this quotation mark should be here, and then the semicolon should be here as well. Okay, and then you select here A, then net is to retract the neural network model. Then here we are using this op from here to pick this data file from here. And then here we are saying that give us prediction for the first row. Okay, considering the data in this file for the first row, give us the prediction. Okay, so then if we simply just run it, this is how our script looks like. Okay, it's rather simple. Then if you just run it, and then we get the output of A. So this would be our predicted value. So let's say if I go here in my optimization Excel file, if I just copy these things and paste it here again, now I'm going to do it for the, we know that this part is actually for the neural network. Okay, A and N, and this part was for the multiple linear regression. Okay, it should be multiple linear RHUB. Okay, so now we got the outcome for the first row, so I'm just going to copy it from here. It's 29 point something. I'm going to copy it and I'm going to paste it here. Then I am going to simply run it once again with for the row 2, and just click here on run. Then we got it for row 2, copy it, and then I'm going to paste it here. Then we can do it for row 3. This is the value we got. Going to paste it here. And finally for row 4. Okay. It might. Did I do something wrong? No, I didn't do something wrong. It looks all right. It looks all right. Yeah, this is just that the value is too low compared to what we have here. Like others, they match pretty well, but this one is pretty low for this one. But then I'm simply going to do this, multiply this FOC with 3.114, the CO2 emission factor. Then I'm going to drag it. And then we can simply calculate this percentage change. So here is the maximum minus the lower one divided by the lower one also. So here we see a huge here we see actually quite huge possibility of change, about 146%. Oh, I think I did a mistake. I should put the brackets here. The brackets are important. So 58%, and if we do the same thing here, this, again I should do the brackets, otherwise again we will get something weird. Okay, divided by, let's say if I use this one, that if I select the percentage here, it's a possibility of about 100% changes. But here this value seems a bit weird, okay, because it seems a bit weird. I would like to really double check what has happened here. Let me try it once again with the column 4. If I open this file, 6.3.11.88.3.1, that's all. That's what we have provided. Actually, now it makes more sense. I think I did something wrong the last time, so now it makes more sense. Yeah, about doesn't make very good sense yet. Doesn't make very good sense yet. If I run it once again, our model is not giving us very good estimation for the fourth one in this case. This one may be a more reasonable one that we are getting. This one could be more reasonable one, around 7% possibility of efficiency change. So here you see when we rerun the models, the results update also time to time, and that's because when we rerun the model, all the weights are re-estimated every time. Okay, and that's why sometimes it can give us some slightly different results. Slightly different results are expected, but like here we had a huge difference. So here it was good to actually have this multiple linear regression results so that we can kind of compare the results with that. Okay. So similarly, now you can actually do the prediction for any given data set. Okay. And my recommendation would be that you try to run these models with varying number of neurons. For example, here, let's say if I actually here we can just change this to 20. Okay. And then here I can make it the first one, and then I run it again. and we got the outcomes. Here we see the overall performance. It looks good. If I click on performance, we see the how the MAC has reduced. Okay, so kind of this is the MAC. Okay, so if we want to report the mean squared error, so this is the value that we should actually report. And if we want to take the root mean squared error, then we just take the square root of this value. Then we will have the root mean squared value. And then we can compare these RMAC values with the ones that we have from the regression. Okay, with the ones that we had in the regression. If I go here and open it now. So in the regression, our RMAC was 7.32. So here we need, when we consider 20 neurons, then if I try to do this square root of 58.2652, I also get something like that, 7.633, something like that. Okay, 7.633 from neural network, and here we get 7.32. So actually here the regression seems to be doing better in comparison to when we consider 20 neurons. So here you can say ANN, number of hidden layer, number of hidden layer, number of hidden layer, you can say 10. And then you can say the same thing down here where you say that it's now 20. Okay, and here we have the outcome for our first one, and we can put it here. Then if we actually, it might be possible to do for all of them at once. So if I just remove it, if I just keep OP, let's see actually if I can get for all of them at once. Actually, yes, that's possible, as you can see. So then we get it at the same time based on the estimation of the model. So that would be better actually to use this one. I'm just going to first paste it here, and then I'm going to convert them from text to columns. Then I'm going to copy and paste them as a transpose. Okay. And then multiply these values with the factor of 3.114 to get the CO2 emissions in metric tons. And then we can do the calculation of efficiency update. Okay. But I recommend that we should try to actually, we should try to remove the observations with really low speed, and I think then our accuracy of our models are going to be improved significantly. Okay, so here again, if I just want to look into the efficiency, this minus this, doesn't matter actually how you do it, you will just get the value in positive or negative. It will be always the same thing. Okay, so here it shows like 90% possibility of achieving energy efficiency. Doesn't look very feasible, but it's okay. And here we get minus this. Here we get about 26%. So it seems we should not be maybe using the one with 20 neurons, 20 hidden layers. Okay, it seems we should not be really using with 20, but you have to compare the MAC for all the models, and then you have to pick the one with which gives you the lowest MAC, and then use that for doing this optimization. Okay, but I'm closing it here now, and I recommend you that you try with the with removing the very slow speed observation and see what you get, and prepare a file, prepare Excel file like this, you know, with this information, how much we are going to save. Okay. Okay, then Bye bye.